Okay, so this is our first video in phase 143, and we want to solve a very simple and fundamental question. And this question is under vectors. Okay, so the question is very simple and it reads this way: determine the direction of the resultant of the two displacement vectors. So d1 given us minus 4i plus 2j m for meters, and d2 read as 2i minus 4j also in meters. Okay, so we have two displacement vectors and we want to find the direction of the resultant. Okay, and resultant over here we mean that the vector sum of the two vectors. Okay, that's what the resultant over here means. So it means that we are going to find a vector d3, okay, which is equal to d1 plus d2. Okay, so that's how we start by solving this problem. So our resultant vector, let's call it d3, and it is equal to d1 plus d2. Okay, so we can say that d3 is equal to d1 is given as minus 4i plus 2j m, then plus d2 is 2i minus 4j m. So d3 is equal to, so over here we add the components, the i's, we add the i's and we add the j's. Okay, that's how we add vectors. So we are going to have into bracket minus 4 plus 2i, so I in meters, then plus in bracket 2 minus 4j also in meters. So d3 is equal to, so minus 4 plus 2 is equal to minus 2. So you have minus 2i, then plus over here we have 2 minus 4. So that will give us minus 2. Alright, so we can simply write this as, so d3 is equal to minus 2i minus 2j, all multiplying meters. Okay, alright, so now this is our resultant vector d3, and the question is asking for, the question says that determine the direction of the resultant of these two vectors. So okay, so the vector d3 is given as minus 2i minus 2j in meters. Okay, so now we want to find the direction of this vector. Alright, so the direction of the vector is defined as phi, and it is equal to the tan inverse of d3y over d3x. Now we already know that the vector d3 can be written in terms of component forms. So we can split d3 into the x component and the y component. Okay, so anytime we want to find the direction of the vector, it is the y component divided by the x component. Okay, so phi will be equal to tan inverse of, now over here the y component is negative 2, then the x component is also minus 2, so this will be equal to tan inverse of 1, and if we find tan inverse of 1 we get 45 on our calculator, but that is not the answer we are looking for. 45 is not the correct answer in this case. The reason is because the vector is minus 2i minus 2j, so if you draw it, it will be in the third quadrant. So let's sketch it for you to have an idea of what you are talking about. Okay, so now if this is the Cartesian plane, then minus 2 on the x-axis should be somewhere here, so minus 2, then minus 2j should be somewhere here, minus 2. Okay, so the vector is somewhere in this quadrant. Okay, the vector d3 is somewhere in this quadrant, and over here angles are always read from the positive x-axis counterclockwise, so angles are read this way. Okay, so this is the angle that we are interested in. Okay, so you read the angle from the positive x-axis towards this towards the side. So because it is in this quadrant, we look for a bigger angle other than 45. Okay, so the angle should be between 270 and 180 degrees. That is the angle we are interested in. So tan inverse of 1 also gives us an angle 225 degrees. So this is the correct solution to this question. All right, thank you very much.